We've already practiced how to test points to see if they were solutions to a linear inequality, and now we're actually going to graph a linear inequality. When I graph a linear inequality, I'm first going to graph the equation as though there were an equal sign. So if this was an equal sign, y equals 2x minus 5, I would start at the point -5 on the y and use my slope of 2, which is 2 over 1, to go up 2 over 1, up 2 over 1, as many times as I thought necessary. Now, if this were an equation, I would connect the dots and move on because I would be done. But we know that this is a linear inequality, meaning there are several solutions. There's an infinite number of solutions. So before we graph that, I want to take you back to when we had something that looked like this. X is greater than 3. And we were just plotting this on a number line. When I plotted this on a number line, I either, because it was a greater than and not a greater than or equal to, I either put an open circle on the 3, or perhaps I put an open bracket on the 3, depending on, which system I was using. And then I plotted all of the values that were greater than 3. So I would shade in to the right or shade in to the right. Same concept is going to happen here on the linear plane or the coordinate plane, as opposed to just one dimension. Now we've got 2 dimensions. The same way that I would use an open circle or an open bracket on a linear inequality, that open would give me a dotted line rather than a solid line. So when I connect the dots here, I'm going to connect it with a dotted or a dashed line. Just like on this inequality, I have to shade in one direction or another. Either my graph will be shaded on this side of this line or on the opposite side of that line. And the easiest way to do that is with a test point, and if possible, I use a test point of 0, 0. A test point is any point that does not fall on the line. So you can choose whatever point you want. 0, 0 it tends to be the easiest one. So if I plug in 0, 0, that means in this inequality, I will replace y with 0, and I will replace x with 0, and I will see if the resulting equation is true. That gives me 0 is greater than 0 minus 5. 0 is greater than -5. That is true. 0 is greater than -5. If it's true, that means everything on the side of the line that contains 0, 0 is true. So everything on this side of the line is true, and that's why it is all shaded. Let's say when I got started, I chose a different test point, like 7, 0. If I plugged in 0 for y and 7 for x, I would end up with 0 is greater than 14 minus 5, and 0 is greater than 9, which is false. If I get a false answer, I don't shade on the side of the test point, but I shade the opposite side, which is the side that I've shaded. The last one I want to show you is if I would have chosen a point that was actually on the line. So let's say 0, -5. If I plugged in 0 for x, and -5 for y, I would get -5 is greater than -5. Now obviously that is false, but see how it's very, very close? And that's why this is a dotted line. Just like on this example, all of the numbers very close to 3 would work, but not 3 exactly. So here are a couple for us to try together, and then you'll have a couple to try on your own. This first one is in slope-intercept form with a b value of 0. So I would start at 0 and use my slope of 4 to go up 4 units over 1 as many times as I need to. And I'm going to connect the dots with a dotted line because there's no or equal to. Now on this particular example, I cannot use 0, 0 as a test point because my line goes through 0, 0. So I would choose any other point you want. I'm going to choose 0, 6. 0, 6. So I'm going to replace x with 0 and y with 6, and I get 6 is less than 0, which is clearly false. So I should not shade on the side of 0, 6. I should shade on the opposite side. So everything on this side would be shaded. On my second example, this is in a different format. This is in standard form, so I would use the cover-up trick to cover up 2x. And remember, when I use the cover-up trick on an inequality, I'm thinking of it as an equation. So I'm going to cover up the 2x and get negative y equals 4, so y is negative 4. And then I'm going to cover up the negative y and get 2x equals 4, so x is 2. And then I'm going to connect the dots, in this case with a solid line, because there is an or equal to. And this one does not go through the point 0, 0, so I'm going to use that as a test point back in the inequality rather than the equation. So 2 times 0 minus 0 is less than or equal to 4. And that gives me 0 is less than or equal to 4. True statement, 0 is less than 4. So this is the side I would shade on. These two are for you to try on your own and then press play to see how you did. My first example here, I could not use the cover-up trick or finger trick on this one, because if I cover up this 2x, I get 3y equals 0, so y is 0. And if I cover up the 3y, I get 2x is 0, so x is 0. So that just gives me a point rather than a line. So instead, I'm going to do a little bit of math magic, and I'm going to turn it into an equal because it's a little bit easier to deal with. And I'm going to turn this into a slope-intercept form. And by dividing by that negative 3, I get y equals 2 thirds x, and then basically plus 0. So I can start at 0, move up 2 over 3, up 2 over 3. Now I'm going to look back at this and say I'm going to have to connect it with a dotted line. And I can't use 0, 0 as my test point yet again because it goes through 0, 0. So now I have to choose any other point. I'm going to choose 0, 7. So I'm going to plug in a 7 for my y value and a 0 for my x value. So 2 times 0 minus 3 times 7 is less than 0, which gives me negative 21 is less than 0, which is true. So I'm going to shade on this side. And the last one, I am going to use my cover-up trick on this one. If I cover up 2x, I get 5y equals 10, so y is 2. If I cover up 5y, I get 2x equals 10, so x is 5. This is a solid line because of the or equal to. I am going to use 0, 0 as my test point on this one. I get 2 times 0 plus 5 times 0 is greater than or equal to 10, which gives me 0 is greater than or equal to 10, which is false. So don't shade towards 0, 0, shade away from 0, 0.